In this video, we're going to look at a couple of examples in terms of verifying trigonometric identities. So in this case, we're going to start with all the basic concepts of how to verify these identities. And in most cases, it's just a number of algebraic techniques. In this particular example, we're going to go ahead and start with the fact that tangent can be reduced or expanded into the sines and cosine functions. So in this case, I'm just going to manipulate the more complicated side, that being this side, there's more stuff here, into sine times tangent. Tangent is sine over cosine added to cosine, and that's supposed to be equal to secant of x. Now I'm going to leave secant of x alone for now. I'm just going to work with just this side. I'll notice here that I can combine the multiplication of sine x times sine x together, making that sine squared. So I'm going to have sine squared x divided by cosine of x plus the cosine of x equals to, and I'm going to go ahead and manipulate this one now. It would have been secant here. I'm going to change it to be 1 over cosine. Very much like that I did with the tangent, I'm going to manipulate both sides of the equations to get the overall equation to be the same concept. Now keep in mind this is an identity, meaning that this here has to be equal to this side. So what we really need to do is manipulate what we have to get either both sides to be the same or to get the two sides equal to each other in a form that we already know is true. What we're going to do next is we'll notice that we don't really like the divisions in these problems. So multiplying by cosine seems like a logical idea. So I'm going to go ahead and multiply by cosine to eliminate this division here. But if I multiply this term by cosine, the whole side has to be multiplied by cosine. So I'm going to go ahead and multiply this piece by cosine as well. And then I'll multiply this side by cosine as well. So again, keep in mind that I'm multiplying all the terms in this equation by cosine of x. So what's going to happen next is the cosine on top here will cancel out with the cosine on the bottom, multiplicatively. I'll be left with sine squared x equals, plus cosine times cosine is cosine squared of x. And on this side, the two cosines are going to cancel out, leaving me with 1. And this identity is now verified because sine squared plus cosine squared is equal to 1. This is one of the Pythagorean identities, and we know it to be true. You don't have to do any more manipulation of that example to prove that this equals to this. And again, that's what the goal is. Does this equal to this? And the answer is yes. In some classes and examples, you might be required to do all this work, get to this, and because you're trying to verify that this identity is true, you'd actually have to start with this form, saying, I know that this is true, let me work my way to get to that. We're not going to go ahead and worry about that particular set of steps. We're just going to go ahead and look at some more examples. So another example we might work with is sine of x minus sine of x times the cosine squared of x equals to sine cubed of x. So this example here, there's a number of different steps we could attempt to take. One of the things in equations, when working with a trigonometric equation, it is highly suggested to avoid dividing by something. The reason why you don't really want to divide by something is because if you divide by something in the equation, you'll eliminate things that you're trying to solve for. Not to mention that when you divide, you're assuming something is true. For instance, if in this situation I divided by the sine of x, then I'm assuming the sine of x can never equal to 0. And that's not necessarily true. So because this is a verifying identity problem, I'm allowed to do that. But more importantly, it's better to realize that in an equation, we shouldn't do that. Okay, so again, in the verifying identity, I think our best bet is to divide everything by the sine of x. I think this will get me to something that I know to be true. This is assuming, again, that sine of x does not equal to 0. If it did equal to 0 in the equation sense, we might have to backtrack and work with some more materials. But for the verifying identities, this is a valid operation and a valid step. Sine divided by sine is 1. Minus, I can cancel out the sine here with the sine here, leaving me with cosine squared of x, and this is equal to sine cubed of x divided by sine of x gives me with sine squared. So you'll notice now that I'm back to the identity of the Pythagorean theorem, such that if I add cosine squared to both sides, that would be verified. It's important to make a statement here that in some classes they'll expect you to get something that is very clearly on the identity sheet. In other cases, for my class, I'm generally okay with you stopping one step away from getting to an identity. It's logical to say, well, I think a student can see that adding cosine squared to both sides is a viable step and relatively a simple, straightforward step. But in some cases, again, you might actually have to show that. We're going to go ahead and do at least one more example in this situation. I think we're going to look at sine of x over 1 plus the cosine of x plus 1 plus cosine of x divided by the sine of x equals to 2 cosecant x. So for an example like this, we're going to have to take some very careful steps to how we deal with it. In most cases, our goal, one of our big goals, is to eliminate all fractions. So we're going to want to multiply by some stuff here in order to remove the divisions here. Again, we could go ahead and distribute divisions. This one we can't distribute because remember, 1 plus cosine of x is one entity in the denominator, and I can't divide the 1 plus cosine x into two separate pieces. So we could distribute this division, but I'm going to start with this right here. I'm going to start with the more complicated piece, and I don't like this denominator. I'm going to go ahead and multiply all the terms by 1 plus cosine of x. This will hopefully get me to something that I can work with. There's also a possible issue that might create more problems for me in the future. But let me go ahead and start with that and see what happens. I'm going to take sine of x. I'm going to multiply, again, the tops and the just the tops by 1 plus cosine of x. That's going to allow that denominator to cancel out. So this is going to be 1 plus cosine of x times 1 plus cosine of x divided by the sine of x equals to 2 cosecant of x multiplied by the 1 plus cosine of x. So this is going to cancel out with this. I'm going to be left with just sine of x there. This stuff here is going to be 1 plus cosine squared. That might cause some headaches for us. Make sure that when we write that out, we actually FOIL it out, distributing the 1 to the 1, the 1 to the cosine, and so on and so forth. If I were to distribute all that out, I'm going to end up with 1 plus 2 cosine x plus cosine squared x. This is still all divided by the sine of x, and this is still all equal to 2 times cosecant of x multiplied by 1 plus cosine of x. I'm going to avoid multiplying that out right now. I think it's going to make things a little bit more complicated if I were to do so. The next step I think that would be most logical is to multiply by sine of x. Again, I'm trying to eliminate all of my denominators here. That might be the most efficient way to do so. If I multiply everything by sine of x, I'm going to multiply this piece by sine of x, making it sine squared of x. If I multiply this whole term by sine of x, it's just going to cancel out that denominator, leaving me with plus 1 plus 2 cosine of x plus cosine squared of x. And if I multiply this side over here by sine of x, I'm going to do something real smooth here, and I'm going to make note that the cosecant of x is the same thing as 1 over the sine of x. So if I were to multiply this whole term by sine of x on top, the cosecant would cancel out with that sine of x, leaving you with 2 times 1 plus cosine of x. I can simplify this side, giving me 2 plus 2 cosine of x, and all I have to make sure that I understand is that this is the more simple side. So this side over here is what I really want to work with. Hopefully at this point, what you might notice is that we have a sine squared and a cosine squared, and they're supposed to be added together. Again, sine squared plus 1 plus 2 cosine of x plus cosine squared. If I take sine squared and cosine squared and I add them together, based on that, once again, Pythagorean identity, I'm going to get 1. So I'm going to manipulate just one side without algebra, but with using an identity. These two pieces added together create, I'm going to put an equal sign here, 1. So I'm going to have 1 plus 2 cosine of x, which is really 2 plus 2 cosine of x. And sure enough, both of those sides are equal to the same thing. So again, there's a number of different ways that we can manipulate identities, equations to verify these identities. Most of these particular cases revolved around using the Pythagorean identity. Keep in mind that it doesn't have to. There are other things that we can do, but the most appropriate few steps that we can start with is, again, working with the more complicated side of an equation, multiplying by a common denominator, and changing pieces of sides of equations in order to create that identity that we already know to be true.